Good morning. I got up again. It's Saturday. Let's start reading. It's 10:15. I'll just follow my list. So then I'm to make some video on my language, Danish, but I was supposed to do it in English. I have some video called aircrafts, but I just do it in my language, Danish. So I like to finish reading about this jet engines so I can close it. So I need a minute to get to my bed. So I will just read to my camcorders out of power. And I'm sorry for the noise from my computer. I need to do this. The electric air blower is making noise. I have to check my cell phone. Nothing there. I have to check the speaker level. 26.
GE Aerospace. For the 1960s incarnation of General Electric's Aerospace Division, see GE Aerospace, 1960s. General Electric Company, doing business as GE Aerospace, is an American aircraft engine supplier that is headquartered in Evendale, Ohio, outside Cincinnati. It is the legal successor to the original General Electric Company founded in 1892, which split into three separate companies between November 2021 and April 2024, adopting the trade name GE Aerospace after divesting its healthcare and energy divisions. GE Aerospace both manufactures engines under its name and partners with other manufacturers to produce engines. CFM International, the world's leading supplier of aircraft engines and GE's most successful partnership, is a 50/50 joint venture with the French company Safran Aircraft Engines. As of 2020, CFM International holds 39% of the world's commercial aircraft engine market share, while GE Aerospace itself holds a further 14%. GE Aerospace's main competitors in the engine market are Pratt & Whitney and Rolls-Royce. The division operated under the name of General Electric Aircraft Engines, GE, until September 2005, and as GE Aviation until July 2022. In July 2022, GE Aviation changed its name to GE Aerospace in a move executives say reflects the engine maker's intention to broaden its focus beyond aircraft engines. In April 2024, GE Aerospace became the only business line of the former General Electric conglomerate, after it had completed the divestiture of GE Healthcare and GE Vernova, its energy businesses division. History, edit. Early efforts, edit. General Electric had a long history in steam turbine work, dating back to the 1900s. In 1903 they hired Sanford Alexander Moss, who started the development of turbojet packages at GE. This led to a series of record-breaking flights over the next 10 years. At first, the role of the high-altitude flight was limited, but in the years immediately prior to World War II they became standard equipment on practically all military aircraft. GE was a world leader in this technology. Most other firms concentrated on the mechanically simpler supercharger driven by the engine itself, while GE had spent considerable effort developing the exhaust-driven turbo system that offered higher performance. This work made them the natural industrial partner to develop jet engines when Frank Whittle's W.1 engine was demonstrated to Hap Arnold in 1941. A production license was arranged in September, and several of the existing W.1 test engines shipped to the US for study, where they were converted to US manufacture as the IAGE quickly started production of improved versions. The I-16, J31, was produced in limited numbers starting in 1942, and the much more powerful I-40, J33, followed in 1944, which went on to power the first U.S. combat-capable jet fighters, the P-80 Shooting Star. Early jet engine work took place at GE's Syracuse, New York, steam turbine, and Lynn, Massachusetts, supercharger plants, but soon concentrated at the Lynn plants. On the 31st of July 1945, the Lynn plant became the aircraft gas turbine division. GE was repeatedly unable to deliver enough engines for Army and Navy demand, and production of the I-40, now known as the J-33, was also handed to Allison Engines in 1944. After the war ended, the Army cancelled its orders for GE-built J-33s and turned the entire production over to Allison, and the Syracuse plant closed. Military and civilian expansion, edit. These changes in fortune led to debate within the company about carrying on in the aircraft engine market. However, the engineers at Lynn pressed ahead with the development of a new engine, the TG-180, which was designated J-35 by the U.S. military. Development funds were allotted in 1946 for a more powerful version of the same design, the TG-190. This engine finally emerged as the famed General Electric J-47, which saw a great demand for several military aircraft. A second manufacturing facility in Evendale, Ohio, near Cincinnati, was opened. J-47 production ran to 30,000 engines by the time the lines closed down in 1956. Further development of the J-47 led to the J-73, and from there into the much more powerful J-79. The J-79 was GE's second hit, leading to a production run of 17,000 in several different countries. The GE and Lockheed team that developed the J-79 and the F-104 Mach II fighter aircraft received the 1958 Collier Trophy for outstanding technical achievement in aviation. Other successes followed, including the T-58 and T-64 turboshaft engines, the J-85 turbojet, and F-404 turbofan. Starting in 1961, General Electric started one of their most important research and development efforts, the GE-1 technology demonstrator, originally designated the X-101. The GE-1 was a basic gas generator, compressor, combustor and turbine, onto which a variety of components such as fans, afterburners or other thrust vectoring devices could be added later. The design incorporated technologies such as a scaled compressor with variable stator vanes, an annual combustor, turbine cooling advancements, and new materials for several government research programs. The U.S. government initially supported development of the GE-1 to produce the J-97 engine. The GE-1 design and technology helped General Electric produce a range of engines, including the GE-1 /6 turbofan demonstrator for the TF-39 engine, the GE-4 for the Boeing 2707 supersonic airliner, and the GE-9 engine for the USAF's Advanced Manned Strategic Aircraft, later GE F-101 engines for the B-1 bomber. The General Electric F101 was later developed into the General Electric F110 and CFM International CFM56 engines. The TF39 was the first high-bypass turbofan engine to enter production. Entered into the C5 Galaxy contest in 1964 against similar designs from Curtiss-Wright and Pratt & Whitney. GE's entry was selected as the winner during the final down select in 1965. This led to a civilian model, the CF6, which was offered for the Lockheed L1011 and McDonnell Douglas DC-10 projects. Although Lockheed later changed their engine to the Rolls-Royce RB211, the DC-10 continued with the CF6. And this success led to widespread sales on many large aircraft including the Boeing 747. Another military to civilian success followed when GE was selected to supply engines for the S-3 Viking and Fairchild Republic A-10 Thunderbolt II, developing a small high-bypass engine using technologies from the TF-39. The resulting TF-34 was adapted to become the CF-34. Whose wide variety of models powers many of the regional jets flying today. In the early 1970s, GE was also selected to develop a modern turboshaft engine for helicopter use, the T700. It has been further developed as the CT7 turboprop engine for regional transports. Commercial aviation power plants, edit. In 1974 GE entered into an agreement with Snecma of France, forming CFM International to jointly produce a new mid-sized turbofan, which emerged as the CFM56. A 50/50 joint partnership was formed with a new plant in Evendale, to produce the design. At first, sales were very difficult to come by, and the project was due to be cancelled. Only 2 weeks before this was to happen, in March 1979, several companies selected the CFM56 to re-engine their existing Douglas DC-8 fleets. By July 2010, CFM International had delivered their 21,000th engine of the CFM56 family, with an ongoing production rate of 1,250 per year, against a 4-year production backlog. The success of the CFM led GE to join in several similar partnerships, including Garrett R Research for the CFE-738, Pratt & Whitney on the Engine Alliance GP7000, and, more recently, Honda for the GE Honda Aero Engines small turbofan project. GE also continued the development of its own lines, introducing new civilian models like the GE90, and military designs like the General Electric F110. GE Aerospace today, edit. GE and competitor Rolls-Royce were selected by Boeing to power its new 787. GE Aviation's offering is the GEnx, a development of the GE90. The engine was also the exclusive power plant on the Boeing 747-8. The Lynn facility continues to assemble jet engines for the United States Department of Defense, subsidiary services, and commercial operators. Engines assembled at this plant include the F404, F414, T700, and CFE-738. The plant at Lynn also produces the -3 and -8 variants of the CF-34 regional jet engine, the CT7 commercial turboprop power plant, and commercial versions of the T700 turboshaft, which are also called the CT7. The Evendale plant conducts final assembly for the CFM International CFM56, CF6, as well as LM6000, and LM2500 power plants. The Durham, North Carolina, facility conducts final assembly for the CFM LEAP, GEnx, CFM56, GE90, GP7200, and CF34 power plants. Crucial parts for these engines are crafted in secondary GE aviation facilities, such as those in Bromont, Quebec, Hooksett, New Hampshire, Wilmington, North Carolina, Asheville, North Carolina, Madisonville, Kentucky, Rutland, Vermont, and Muskegon, Michigan, where the engine blades and vanes are manufactured. Smiths Group and General Electric announced on the 15th of January, 2007, that the former was divesting Smiths Aerospace to the latter for £2.4 billion, US $4.8 billion. GE Aviation closed the transaction on the 4th of May, 2007. Smiths Aerospace, which was an important supplier, became an operating subsidiary of GE Aviation known as GE Aviation Systems. This acquisition will reportedly give the combined unit the clout to resist pricing pressures from its two largest customers, Boeing and Airbus. Analysts further assert that it enables General Electric to acquire assets similar to those it desired in its failed bid for Honeywell in 2000. Along with the purchase of Smiths Aerospace, the purchase included opening the first University Development Center at Michigan Technological University in Houghton, Michigan, in the effort to work with engineering students to provide training in engineering and software development. The program has performed well and GE Aviation has announced further UDC openings at Kansas State University. In July 2008, governments in the Persian Gulf reached agreements with GE to expand engine maintenance operations there. The Wall Street Journal reported that Mubay Dele Development Company, which owns Abu Dhabi Aircraft Technologies, an overhaul and maintenance company, signed an agreement worth an estimated $8 billion with GE. Abu Dhabi Aircraft Technologies will maintain and overhaul GE engines used in commercial aircraft purchased by airlines based in the Persian Gulf. On the 23rd of December, 2012, GE announced that it has agreed to purchase the aeronautical division of Avio, an Italy-based manufacturer of aviation propulsion components and systems for civil and military aircraft, for $4.3 billion US, €3.3 billion. GE Aviation follows through to develop a supersonic engine concept for Ariane with a configuration accommodating reasonably well requirements for supersonic speed, subsonic speed and noise levels. On the 18th of July, 2022, GE announced that GE Aviation had been renamed GE Aerospace, and would become the successor to the GE company once the spin-offs of its subsidiaries are completed. GE Aerospace will own the GE trademark and logo, and will license the brand to the other companies, GE Healthcare and GE Vernova. Additive manufacturing, edit. Recently, they have started incorporating 3D printing technologies in their engines and have incorporated the manufacturing process in the newly designed GE9X, the largest jet engine in the world. GE acquired Arcam EBM for electron beam melting, concept laser for laser melting, and material provider AP&C metal casting improves through competition with metal additive manufacturing, for which GE Additive believes it will soon compete with metal forging, which will then be enhanced in response. Additive manufacturing is focused on new builds but can be used for part replacement. When complexity rise, costs can stay level. For example, replacing a turbine consisting of 300 components with one piece. The electron beam melting has good speed for economy, precision to reduce processing work, and size capability for larger parts. The hot process reduces stresses in the part and penetrates deeper than laser for thicker parts with coarser, cheaper metal powders. Additive techniques can be used across the engine and even in the over 1500 degrees Fahrenheit, 820 degrees Celsius, hot section. They are used in the CT-7 combustor liner, For GE9X low-pressure turbine blades, the first rotating parts, and for 16 parts in the ATP, including an 80 parts heat exchanger consolidated into one. Products, edit. Turbojets, edit. Model name thrust. General Electric IA 1250 lbf, 5.6 kN. General Electric J31 1650 lbf, 7.3 kN. General Electric J33 4600 lbf, 20 kN. General Electric J35 5600 lbf, 25 kN. General Electric J47 5970 lbf, 26.6 kN. General Electric J79 11870 lbf, 52.8 kN. General Electric CJ805 11650 lbf, 51.8 kN. General Electric J85 2,405,000 lbf, 1122 kN. General Electric CJ610 3100 lbf, 14 kN. Turbofans, edit. Model name thrust. General Electric CJ805-23 11650 lbf, 51.8 kN. General Electric CF700 4200 lbf, 19 kN. General Electric TF39 43300 lbf, 193 kN. General Electric CF6 41500 lbf, 185 kN. General Electric F101 17390 lbf, 77.4 kN. General Electric TF34 9275 lbf, 41.26 kN. General Electric CF34 9220 lbf, 41.0 kN. General Electric F404 11000 lbf, 49 kN. CFM International CFM 5624,00021,580 lbf, 106.896.0 kN. General Electric F110 17155 lbf, 76.31 kN. General Electric F118 19000 lbf, 85 kN. General Electric YF120 23500 lbf, 105 kN. CFE 738 5900 lbf, 26 kN. General Electric GE 9081,0001150,000 lbf, 365 10 kN. General Electric F414 13000 lbf, 58 kN. GE Honda HF 122050 lbf, 9.1 kN. General Electric /Rolls-Royce F136 25000 lbf, 110 kN. Engine. Alliance GP 7281,500 lbf, 363 kN. General Electric GX 69800 lbf, 310 kN. CFM International LEAP 32160 lbf, 143.1 kN. General Electric Passport 17,745 18,920 lbf, 78.9384.16 kN. General Electric GE9X 110,000 lbf, 490 kN. General Electric Affinity 16,00020,000 lbf, 7189 kN. Turboprops, edit. Model name power. General Electric T31 2300 HP, 1700 kilowatts. General Electric T700 1735 HP, 1294 kilowatts. General Electric H8800 HP, 600 kilowatts. General Electric Catalyst 1300 HP, 970 kilowatts. Propfans, edit. Model name thrust. General Electric GE 3625,000 lbf, 110 kN. Turbo shafts, edit. Model name power. General Electric T58 1250 HP, 930 kilowatts. General Electric T64 4330 HP, 3230 kilowatts. General Electric T700 1622 HP, 1210 kilowatts. General Electric GE 38 7500 HP, 5600 kilowatts. Industrial and Marine Turbines, edit. Model name power. General Electric LM 500 4.5 MW, 6000 HP. General Electric LM 1500 7.4 MW, 9900 HP. General Electric LM 1615 MW, 20,000 HP. General Electric LM 2525 35 MW, 34,000 47,000 HP. General Electric LM 5000 35 MW, 47,000 HP. General Electric LM 6000 41 52 MW, 55,000 70,000 HP. General Electric LM 9000 65 MW, 87,000 HP. General Electric LMS 100 MW, 130,000 HP. See also, edit. 1 Larchan Lindsay. 2 Berhard Newman. 3 University Development Center. References, edit.